over to Niels Jan van Eck.
Hello, Todd.
We are so far into this 24 hours right now, and I'm surprised at how smoothly everything has gone. I was expecting at least at some point to have a panic moment where we'd lose. Now, I suppose now that I've said that, of course it's going to happen, but I'm really glad that that it's gone smoothly, and so it's great to see you. And I'm just going to read a brief bio here. Niels Jan van Eck is a senior researcher at the Center for Science and Technology Studies, Leiden University in the Netherlands. He's doing research in the field of bibliometrics and scientometrics. His research focuses on the development of visualization tools and algorithms, mainly for analyzing the structure and development of science. He's the main developer of the VOS Viewer and the CITNet Explorer, two well-known software tools for visualizing bibliometric data. The VOS Viewer software is frequently used in bibliometric studies. More than 2,500 publications have appeared in international scientific journals in which the software is employed. So in addition to his work on bibliometric visualization, he also focuses on the study of bibliometric data sources and the analysis of the full text of scientific publications. He has published in more than 70 publications. He has published more than 70 publications, and he is editor of Brief Communications of the Journal of the Association for Information Science and Technology. He also serves on the editorial boards of Journal of Data and Information Science and Quantitative Science Studies. And he's an elected board member of the International Society for Informametrics and Scientometrics. And he's also the contributor to Places and Spaces, which is where I first encountered him a few years back. And I think we may have exchanged some emails in the workup to presenting that work. And so I'm going to just kind of hand the floor to you, and you can take it away. So thank you again for joining with us.
Okay, thanks a lot, Todd, and also thanks a lot for running this marathon on mapping science. It's really impressive. Yeah, so thanks first of all for inviting me to also share some of my work. So good evening, Asia, and good afternoon, Europe and Africa, and good morning, everyone in North and South America. The topic of my presentation today is visualizing science using VOS Viewer, and I will start sharing my screen. So if it is correct, my screen should now be visible.
It's correct. Yep, we can see it.
Yeah, okay, thanks a lot for the confirmation. So the topic of my presentation is visualizing science using VOS Viewer. Well, together with my colleague Ludo Wadman, I have developed VOS Viewer. VOS Viewer is a software tool that is widely used by researchers in bibliometrics and scientometrics. It's a powerful tool that can be used to analyze and visualize scientific literature. The tool can, for example, be used to get a quick overview of the structure of scientific fields, the main topics that are studied in the field, and the main researchers that are active in the field. I'm a senior researcher at the Center for Science and Technology Studies, CWTS. And CWTS is a research center of Leiden University that is specialized in quantitative analysis of scientific research. With our studies, advice and insights provided by the tools that we build, we try to make the science system a little bit better. My research at CWTS focuses on the development of visualization tools and algorithms, mainly for analyzing the structure and development of science. And VOS Viewer, the software tool that we are going to focus on today, is one of the outcomes of this research line. But let us first go to the problem statement of today. every day, many new scientific publications appear in the literature. As researchers, we have the challenge to deal with this enormous amount of available literature. We have to filter this enormous amount of literature in order to identify those papers that are relevant for our research. And the growing amount of literature doesn't make this task any easier. The title of an article published in Science magazine is, for example, an illustration of this. So it's visible on the left on the slide, and the title says, "Scientists are drowning in COVID-19 papers." And this paper was published just at the beginning of the pandemic in May 2020. In the article, a researcher mentions that in 1 week only, more than 4,000 papers were published on the topic of COVID-19. And he continues by saying that he is not able keeping up. So already at that time, there was an enormous amount of literature on COVID-19. The article therefore asks the question whether tools can be of help. On the right, I have put some other quotes that also illustrate this problem. So a new scientific paper is published every 30 seconds, and there are 10,000 updates to PubMed every day. And PubMed is a database that contains information on scientific literature in the biomedical and health sciences. And another quote, "It is impossible for humans alone to process all of the complex information potentially available to them for the advancement of scientific research." So this raises the question, can tools be helpful to get an overview of the relevant literature? Now, luckily, a lot of information and data is already collected and stored in databases, and we call those databases bibliographic databases. A bibliographic database contains the metadata of scientific publications. So it contains, for example, the title of a publication, the authors, the affiliations of the authors, an abstract, so a very brief summary, the source in which the publication has been published, and also very important, a reference list. So pointers to previous work that is related. And nowadays we have many different data sources containing this type of metadata of scientific literature available. So we have the more traditional data sources for which you need a subscription, but we see also an increasing trend in new data sources that offer the data for free and that have all kinds of possibilities to also automatically connect tools to those open data sources. So there is a lot of data and information available on scientific literature. Now on this slide, I've put some figures to give you an idea about the size of those data sources. So in Web of Science, Scopus and Dimensions, we have information available of more than 20,000 journals. And those databases, they contain data on more than 50 million publications, and there are more than 1 billion citation relations between those publications. So we are really talking about big numbers. And out of those bibliographic databases, we can extract all kinds of networks that can be helpful to study the structure of science and the evolution of science. The most straightforward type of network is a citation network of publications. In such a network, the nodes denote publications, and a link between two publications denote a citation relation. So one publication is citing another one. So in fact, the bibliographic databases can be represented as huge citation networks containing 15 million nodes and more than 1 billion links between the nodes. Then we have also co-authorship networks of authors, organizations, and countries that we can extract from those bibliographic databases. And these types of networks are especially helpful to study how researchers, how organizations, how they collaborate with each other in science. Then we have co-citation networks and bibliographic coupling networks. And finally, co-occurrence networks of keywords and terms extracted from titles and abstracts of scientific articles. And this latter type of network is especially helpful to get a quick overview of the main topics that are studied within the field and to study how those topics are related to each other. So we can extract different types of networks from those bibliographic data sources. And those networks can be really, really large. And therefore, we also need tools in order to visualize the most important patterns from those networks. So this brings me to the next part of this presentation, in which I would like to focus on some tools that we have developed at CWTS to analyze and visualize those networks of scientific literature. So the first tool that we have developed at CWTS is a tool called VOSviewer. Now, VOSviewer is a software tool that is widely used by researchers in the field of bibliometrics and scientometrics. As I already mentioned, the tool can be used to analyze and visualize scientific literature. That the tool can, for example, be used to get a quick overview of the structure of scientific fields, the main topics that are studied, and the main researchers that are active in the field. Here we see the user interface of VOSviewer. The network that is visible is a co-citation network of journals in the field of economics and management. And we can see that VOSviewer in this case has identified 5 main groups of journals. So each circle in this case represents a journal, and the colors represent the main groups of journals that have been identified. In red, we see, for example, journals from economics. Then in purple, we have accounting and finance journals. In green, we have management journals. In yellow, marketing. And in blue, we have operations research. Now, VOSviewer has zoom and scroll functionality available that can be used to explore those maps in full detail in an interactive way. So if you are, for example, interested in the economics journals, then you can zoom into this part of the network and you can inspect that part of the network in more detail. We have also different visualization functionalities available, different options, and in this way you can change also the way in which the network is visualized. And we see some examples on the right. Now, VOSviewer has become a quite popular tool among individual researchers who want to get a quick overview of the scientific literature in their own field. Now, on this slide, we see the number of papers published in international scientific journals in which the tool has been used. We see a clear increasing trend. In total, the tool has been used in more than 3,000 publications. The tool is not only used by individual researchers, but also by research institutions, for example, directors of departments at universities. It's also used by research funders, scientific publishers to get an overview of their journal portfolio, for example, and companies, industry. Here we see a large-scale example of VOSviewer. And we also see a QR code in the top right. And I would like now to encourage you to take your mobile device, a tablet or a phone, and scan the QR code. And what will happen then is that this visualization will be opened on your mobile device. The visualization will be opened in VosViewer Online, a web-based version of VosViewer, and so it will run in the browser. And then you can immediately start to explore exactly this visualization in an interactive way on your mobile device. So grab your mobile device, scan the QR code, and start exploring this visualization. In the meantime, I will explain what this visualization is about and what we can learn from this. As I already mentioned, it is a large-scale application of VosViewer. It's a co-authorship network of organizations worldwide and how they collaborate. This visualization was constructed based on millions of publications and tens of millions of co-authorship relations. So we collected millions of publications from the Dimensions database, and we analyzed the affiliations of the authors of those publications. And based on their co-authorships, we have been able to visualize how organizations, how research organizations, how they collaborate with each other. And this is the structure that is created by VosViewer. And by looking at the different groups, visualized using colors, we see the following. So more or less each color, each group represents research organizations from the same country. So in yellow, we see, for example, Japan. In green, we see China. The US is available in red. Below the US, we have a group of organizations from Canada. Over here, we have Australia. And at the right, we have countries from Europe. So the UK, Germany, Switzerland, France, Belgium, and also the Netherlands. So in Europe, it is more mixed up, the collaborationships. So we can ask ourselves the question, what can we learn from such a visualization? Well, we all think that we are quite globalized nowadays. So in research, we frequently work together, and we also collaborate with partners in other countries, with partners from abroad. But what we can learn from this particular application is that if we collaborate in science, that we still have the tendency to collaborate with our near neighbors. Let's look at another example. Again, a large-scale example. And again, we have a QR code available so that you can open this visualization yourself on your mobile device and start exploring this visualization in an interactive way. So in this case, we see a journal citation network. So each circle, each node represents a journal. And the journals are connected to each other using citation relations. So publications are published in the journals, and the publications, they cite each other. And based on this information, we have created this visualization using VosViewer. So again, it is based on millions of publications and tens of millions of citation relations. The interesting thing about this visualization that it has been constructed based on data that is freely available in Crossref. So this is a study that you can easily do yourself using VosViewer and freely open data. So let us look at the structure of this visualization, because that is quite interesting. In red, at the bottom left, we have journals from the social sciences and psychology. Then we go to green, biomedical journals. And in light blue, we see journals from the life sciences, dark blue, earth and environmental sciences. In yellow, we have journals from chemistry. In orange, we see physics. And then we go to purple, engineering, statistics, mathematics, and computer science. And then we are back at the social sciences. And this structure that is visualized using VOSviewer, it is in the data. So it's not something artificial that was produced by VOSviewer, but it is really extracted from the data. And it also resembles the so-called consensus map of science. So this circular-like structure of all the main disciplines and how they are organized and related to each other, it is sometimes referred to as the consensus map of science. And different researchers have observed this overall structure of science using different tools and different data sets. In VOSviewer, we have also text mining functionalities available. So we have implemented natural language processing techniques in order to support users to extract important terms from titles and abstracts and to visualize based on how these important terms, how they co-occur in a two-dimensional visualization. And then so-called term maps can be constructed. And here on this screen, we see an example of a term map. It's a term map based on publications from my own field of science, the field of scientometrics. And then, well, we see that we see a clear overview of the main topics that are studied within my field. So in this case, we see 4 colors, so 4 main topics. And because I'm a researcher active in this field, it's very easy for me to identify what those topics, what they mean. So in red, we see, for example, information retrieval and information behavior. So we see terms like behavior, user, participant, but also algorithm, task, precision. So this is all about information retrieval. And then on the left, we see topics that are more towards bibliometrics. In green, we see citation analysis and bibliometric indicators. So we see terms like H-index, impact factor, journal impact, citation impact. So it's very clear that it is about citation analysis and bibliometric indicators. And in blue, we see terms like collaboration, country, growth, and all kinds of country names. So this is how we collaborate in science. So that is also a popular topic that is studied. And in yellow, we see terms like co-authorship network, social network analysis, citation network. So this is about, well, the topic of today's presentation, visualizing science. And we also see patent analysis. So this is how term maps can be used to get a quick overview of, well, the main topics that are studied in the field, and to see also how the topics, how they are related to each other. But we can do more using the term maps. We can also create so-called overlay visualizations. And we see 3 examples at the right. In those so-called overlay visualizations, the structure of the visualization is the same. So the location of the terms in this case, they are exactly the same. The only thing that is different are the colors. Using a color, we can visualize a different type of information on top of the structure of the term map. And in this case, I have visualized the topical focus of 3 main journals in my field of science. So on top, we see the activity of the Journal of Infometrics. So we can see that this journal, it is focusing mainly on citation analysis and bibliometric indicators. Scientometrics, this journal is focusing on a lot of the scientometric topics on the left, and it has a special focus on collaboration studies and visualizing science. And then finally, JSIST, yeah, it is really focusing on information retrieval and information behavior. The development of FOSS-Viewer, it is a long-term commitment. So we already started with the development back in 2009. And throughout the years, we have implemented many new features, and we have implemented support for many new types of analysis. In the most recent years, we have also focused on implementing support for new data sources that can also be used free of charge, and that also provide APIs, and I will come back to that later. Last July, we have also launched FOSS-Viewer Online. I already mentioned it. It's a web-based version of FOSS-Viewer, and FOSS-Viewer Online allows users to easily open visualizations in the web browser and to easily share their results with others in this way. It's, for example, also possible to embed interactive visualizations using FOSS-Viewer Online in websites, web pages, and blog posts, for example. On this slide, we see an overview of all the different types of analysis, the different visualizations that we support for the different data sources. And I will quickly say something about how the data access works, because FOSS-Viewer is a tool without any data. So we need to work with those bibliographic data sources to first collect our data. So in the case of the more traditional data sources, we have the following procedure available. So as a user, you can go to the website of those data sources. You can perform your query, so your search for relevant literature, and then you can export the results. So you can download the metadata of the publications that you selected, and you can download this data using in files. And those files, they can then be provided as input to FOSS-Viewer. For the open data sources, we have an alternative route available. And that is also a more convenient route. So most of the new data sources, they have so-called application programming interfaces available. So APIs. And we have connected FOSS-Viewer to those open data sources by making use of the APIs. So as a user, you don't have to download manually some files. In FOSS-Viewer, you can immediately query those open data sources. And here on this slide, we see how the interactive querying, how it works. So in FOSS-Viewer, we have a wizard available, and on the left, we see one screen of the wizard in which we can search in Microsoft Academic for relevant literature. So we can search, for example, based on author name, affiliation, journal name, or based on keywords that appear in the title or abstract. And I will now quickly show a pre-recorded movie that demonstrates how this interactive querying, how it works. So in this case, we are going to work with Microsoft Academic, and we are going to search for all the publications published in Journal of Informatics. In the case of Microsoft Academic, we have to provide an API key, but you can obtain one for free. And now in the background, the relevant publications are retrieved using the API connection. So we have retrieved 1000 publications, and we can immediately start to visualize this data. So different types of visualizations are available. And in this case, we have visualized a co-authorship visualization. So this visualization now provides us how authors active in the field, how they are connected to each other based on co-authorship relations, so how they collaborate with each other. So let us quickly look again how it works. So that data is now downloaded in the background. Using the API connection, we see an overview of all the retrieved publications. So 1000, we're going to visualize a co-authorship network of researchers. So this visualization now provides us with an overview of the most important researchers or the most active researchers and how they are connected to each other. And then we can also identify different research groups and how they collaborate. So another example, in this case, we are going to create a term map. Again, using Microsoft Academic. And we are going to search for COVID-19 related research, so coronavirus related research. So this is a demonstration that I recorded some time ago. So at that time, we retrieved 3,000 relevant publications. So this was really at the start of the pandemic. And now in the background, important terms are identified in the titles and abstracts, and they are visualized based on co-occurrence relations, so how they co-occur in the titles and abstracts. And then FOSView has identified three main topics. In green, we see well, topics around the healthcare system, so hospitals, and the treatment of patients. Blue, biomedical research on the virus itself, and in red we see how to govern and how to manage the outbreak with all kinds of measures and yeah, things like that. So this is another example. In this case, we are going to use another data source, Europe PMC. So it's a data source containing literature on biomedical and health related publications. And well, we have searched for all the publications of one particular researcher. So let's look at this again. So we search for all the publications of one particular researchers. So almost 100 publications, and we visualize all the collaborators of this researcher. So in this way, we get a quick overview of the collaborationship network of this researcher. Now we have also created another tool. And this tool is called SIDNet Explorer. And as the name suggests, this tool can be used to explore citation networks. So publication citation networks. In this case, in this tool, we take a timeline-based visualization approach. So in the visualizations, the vertical axis represents time. The other dimension, the horizontal dimension, is used to represent the relatedness between publications. So in the visualizations, we visualize the most important publications, so the most highly cited publications in the data set, and we locate them based on publication year and horizontally based on how they are related to each other. And in this way, different streams of literature become visible, and we can analyze how publications, how they build upon each other. So in this case, we see three streams of literature, one in purple, one in blue, and one in green. The interesting thing about SIDNet Explorer is that it is a tool that has support for analyzing very large citation networks. So we have support for while analyzing networks containing millions of publications and tens of millions of citation relations. And then we have interactive functionalities available to make all kinds of selections of publications and to perform drill downs into certain parts of the network. And in that way, different streams of literature can be analyzed in more detail. It turned out that this tool, CITNET Explorer, is especially helpful in making literature reviews. And on this slide, we see an example of a literature review on citation impact indicators. It contains almost 400 references, and this literature review has been constructed by making use of CITNET Explorer. Okay, so let us now look at the network analysis techniques that we have implemented in both tools, so in VOICEViewer and in CITNET Explorer. So there are actually two techniques that play a crucial role in our software tools. A so-called layout technique and a clustering technique. The task of the layout technique is to go from an unorganized network to an organized network. So an unorganized visualization in which nodes are located randomly to a situation in which nodes are located at a particular location. And nodes should be located in such a way that strongly related nodes are close together in the two-dimensional space. So this is the task of the layout algorithm, to create a structured visualization in which the distances are of importance. And sometimes this process is also called mapping, so the mapping of science. In VOICEViewer, we used a technique that is called visualization of similarities. So this is the layout technique that we use, and this is a technique that we have developed ourselves. Then we have also clustering, and this is the task to go from an unclustered network to a clustered network. So the task is to group nodes together that are strongly related to each other, for example, based on citation relations. So in this case, we see three groups. So the blue nodes are strongly related to each other, the green ones and the red ones. That is the idea of making a clustering. And sometimes this process is also called community detection. And we use the Leiden algorithm for this task. Here we see a publication that we have published about our layout technique, the VOS layout technique. So our technique can be seen as an alternative to multidimensional scaling. So this is a popular technique that is used in statistics. On this slide, we see a paper that we have published on the Leiden algorithm. And the Leiden algorithm can be seen as an improvement over the well-known and popular Louvain algorithm. Now, the Louvain algorithm has some problems. We have, for example, shown that the Louvain algorithm has a major defect that largely went unnoticed. The Louvain algorithm may yield arbitrarily badly connected communities. And in the worst case, communities may even be completely disconnected. So in the case of a citation network, it can happen that publications are grouped together while they don't have any citation relations with each other. Well, this cannot happen with the Leiden algorithm, so we have some guarantees, theoretical guarantees. And it's even better, so we do not only guarantee better clustering solutions, but the cluster solutions can also be obtained much faster. We make our clustering technique and our layout technique also open source available on GitHub. So this makes it possible for researchers to also implement these types of techniques in their own tools. So let us now look at another topic that we frequently focus on at CWTS, and that is the construction of so-called publication classification systems of science. So at CWTS, we create detailed classification systems of science in which we assign individual publications to topics. So most classification systems that are nowadays available, they are based at the journal level, and this has some drawbacks, of course, especially for multidisciplinary journals like Nature and Science. So typically what happens is that all the publications published in a journal are assigned to the same topic, and well, this has some drawbacks for the multidisciplinary journals. So what we do is we create classifications at the publication level, and we use our Leiden algorithm to create the publication level classification systems. Because our algorithm is very efficient and powerful, we can take a large body of literature and we can easily create those classification systems of science. So the most recent version that we created is based on all articles, reviews, letters, and proceedings papers in the Web of Science from the period 2000-2020. So we are talking about 30 million publications and almost 600 million citation relations between those publications. And this was the input for the Leiden algorithm. And then we constructed a classification system of 4 hierarchical levels. So at the highest level, we have 5 main fields of science. Then we have 24 broad disciplines, 812 fields, and at the lowest level, we have 4,000 subfields. And this is a visualization of the publication level classification system at the lowest level, so at the level of 4,000 subfields. So each circle, each node represents a field of science. So a group of publications that are strongly connected to each other by using citation relations. So we have 4,000 fields, and well, they are also connected using citation relations, and we have used this data to also create a Vossview visualization of the publication level classification system at the 4,000 field level. And then this structure appears. So again, we see the consensus map of science appearing. So in red, we have the fields from the social sciences and humanities. In green, we have the biomedical and health sciences. In yellow, life and earth sciences. In blue, the physical sciences and engineering. And in purple, we have mathematics and computer science. And my own field of science, scientometrics, is located in the social science and humanities part of this map. And on this slide, we see a summary card of well, the content of this cluster. So this subfield of scientometrics. And in this summary card, we see well, a list of characteristic terms extracted from titles. So that gives us a clear idea that this is indeed a cluster that is about scientometrics. we see the publications with most citations. So those publications typically also provides a clear ID on, well, the topic of a cluster, of a field. And in this case, we see a publication by Heers on top, and it's about a bibliometric indicator. We also see the number of publications over time, so we also see a clear increasing trend. This is another visualization of this Scientometrics subfield, and this one is constructed by VosViewer. So it is a citation network of publications. So in this case, each node is a publication, and we see how the publications are connected to each other based on citation relations. And then again, different topics appear. So in red, we see all kinds of publications about science mapping, so the topic of this event. In green, we see collaboration in science. In yellow, we see studies on a particular bibliometric indicator. In light blue, we see how it is mentioned in social media, for example, and so on. Another visualization based on the same field, and this time it is a term map constructed again using VosViewer. So we have taken all the titles and abstracts of the publications of this Scientometric subfield, and we created a term map using VosViewer, and this then again provides with an overview of, well, the different topics that are studied and how those topics are related to each other. So collaboration studies, bibliometric indicators, the visualization of science, open access publishing, careers and gender, and a medical topic and peer review. Another type of visualization, this time constructed using Sitent Explorer, and well, this provides with an overview of the most highly cited publications within Scientometrics. And in this way, we also can identify or analyze developments over time, and we can identify different streams of literature. So in blue, we have the visualization of science, and in green, for example, bibliometric indicators. And in orange, we see, for example, altmetrics. So that is an upcoming topic. Okay, let us go back to this overall map and structure of science. So also in this case, we can create overlay visualizations. And here we see an example. This example is showing us a time trend. So the structure of the visualization is the same. So the locations of the fields are the same. The only thing that is different are the colors. And now the colors represent the average publication year of the publications in a particular field. So red, in red, we see the fields that contain publications that are relatively young. So fields that have received a lot of recent attention. And then we can identify, for example, these types of fields. So a field focusing on graphene research, one on microRNA, obesity, and diabetes, but of course also coronavirus-related research. Here we see a summary card of the graphene subfield. And if we then look at the most highly cited publication in this field, then we can see that it is authored by one of the Nobel Prize winners. Another example of an overlay visualization. Here we see the publication output of my own university, Leiden University. So we can see that, well, it's a broad university focusing on many different fields. so astronomy, physics. There's also a lot of activity in the biomedical and health sciences because well, we've also a medical faculty, a medical center, and a lot of attention for the social sciences and humanities and computer science. You can do the same thing for whole countries. So here we see the activity of China, so the publication output of China, and then we can observe that well, researchers from China, they are mainly focusing on computer science, engineering fields, and there's less attention for the social sciences, for example. But we can also use those overlay visualizations and this overall structure of science to study interdisciplinary fields or interdisciplinary topics. And the coronavirus related research is nicely illustrates this. Of course, it's to be expected that there's a lot of research going on in the medical fields. So we see a lot of publication output over there in this part of the map of science, but we also see activity in other parts of the visualization of science. And if we have a closer look at well, the topic of those fields, then it also makes sense. So we see, for example, a lot of research on mathematical models and infectious diseases. So how to model this and how to predict how the virus is spread. We have complex networks and epidemics. We have a topic on crisis communication and management, so how to communicate about particular measures. Of course, the pandemic has also a big impact on tourism, so we see also an increased number of publications in that particular cluster. A cluster on loneliness and social isolation. Of course, the lockdowns, they have also consequences. And this is also studied. Risk analysis and social media and fake news. So how to deal with this, and this is also studied by researchers. So we have seen well, a lot of examples. I've provided you with information on the different tools, the different techniques that we have available, and I would like to encourage you to try out those tools and techniques yourself. So we have some websites available for you. So the VosViewer website and the System Explorer website, for example, and you can go to the website, you can download the tools for free, and you can immediately start working with the tools. We have also a lot of documentation available. So we have a getting started page available with tutorials, a video, and other documentation. If that is not enough, then we also offer courses and workshops. And the next course is this January. And in the course, participants are introduced into the main techniques for visualizing science. So we like to give those courses and workshops in a classroom so that we can communicate with the participants in an easy way, and that we can also can engage the participants, and that we can work together on assignments, and that we can have lively discussions. But well, nowadays we also do it online. So in the past 2 years, of course, due to the pandemic, we have to look for other ways to offer our courses and workshops and tutorials. And well, this is how it looks like nowadays. And well, working in an online setting turns out also to be beneficial. So we can include more participants, and also participants from more remote areas, for example. Finally, I would like to close my presentation with the following. So when I'm at home, then my children frequently ask me the question, what I do at my work, and then I have to explain in very simple words what I'm doing, and that I'm creating tools well, to visualize topics in science and how they are related to each other. And well, I told my 10-year-old daughter about also this event, and she became very enthusiastic, especially when I also told her about well, one particular element in the program, especially for children. And she immediately well, started to draw a science map. And well, it's a drawing on topics that she discusses at school. So that is her view on science, so to say. And well, she asked me to show this drawing and to also explain it a little bit. So on the top left, we have well, some pictures that are dealing with language. And then we have a picture about the history of science with a pyramid from Egypt and a mummy. And then we go to well, the life sciences, nature, the earth and environmental sciences with well, a picture of the Netherlands, so a map of the Netherlands. And over here we see the sea and a water barrier protecting the lowlands of the Netherlands. Then we have well, medical pictures, engineering, mathematics, and well, then we are back at the languages. And well, I was very surprised to see all of this, because yeah, it nicely connects to everything that I showed in this presentation. So thanks a lot for your attention. Yeah, I'm very happy to take any questions.
That's very brave to show that at the end at risk of being upstaged by your own daughter. That was wonderful. That was great. Thank you so much. Thank you for taking us through these tools. I just wanted to ask you how you developed your interest in scientometrics. How did that come about? Were there any like burning questions that you had that you needed to answer, and this was the venue, this was the vehicle through which to do it?
Yeah, that brings me back to well, my master's study. So during my master's, it was in computer science. I was very interested in well, also summarizing text documents, so not necessarily scientific publications, but documents in general. And I was involved in a project in which we wanted to extract relationships out of textual data. And at that time, it turned out that that was yeah, a bridge too far. It was too difficult with the given techniques and the computer power. So it was too difficult to exactly, very accurately to extract the type of relationships between yeah, objects or entities mentioned within a text. But what I found out is that in the field of scientometrics and bibliometrics, they already yeah, did quite advanced things with measuring the strength of relationships between objects. So the very simple principle that we still use in our current tools to look at how entities, how they co-occur, and just count how frequently they co-occur in different documents. And the more entities co-occur, yeah, the more evidence you have that they are in some way related to each other. So that brought me to the field of scientometrics.
Awesome. Well, thank you so much for your time. Thank you for sharing your work, and thank you to your daughter for sharing her work. This has been really great. And Yeah, enjoy the rest of your weekend, and thanks again for giving up an hour of your time. Appreciate it.
Yeah, thanks a lot.
Okay.